So all kinds of laws govern our everyday life. Traffic laws tell you that you have to stop at stop signs. Tax laws demand that you give a portion of your salary to the state and the federal government. Even scientific laws apply to everyday life. For instance, the law of gravity predicts a pretty poor outcome for someone attempting to fly. Another set of scientific laws that affect our everyday life are the laws of thermodynamics. So let's consider a few examples to try to understand how the laws of thermodynamics apply to everyday life. The first law of thermodynamics states that energy can't be created or destroyed, but you can convert it from one form to another. This is also sometimes referred to as the law of conservation of energy. So how does this apply to our everyday life? Well, let's consider the computer that you're using right now. Right? It's powered by energy. But where did that energy come from? Well, the first law of thermodynamics tells us that this energy couldn't have appeared out of thin air. So it came from somewhere. So let's start tracing that energy back. So we know that our computer is powered by electricity, right? But where did that electricity come from? Well, it came from a power plant. Now, the power plant could have produced that electricity in any number of ways. Let's consider the example where the power plant is specifically a hydroelectric power plant. So a hydroelectric power plant is going to be associated with a dam, right? And that dam is holding back a river. A river has kinetic energy associated with it, meaning that the river is moving, it's flowing, it has kinetic energy, right? The dam then is converting that kinetic energy into potential energy. So I've stopped the water from flowing, and I'm creating this potential energy where the river wants to continue to flow and release that potential energy that is being stored up by the dam. The way a hydroelectric power plant works then is that we can release some of this water into our hydroelectric plant. And I can use the water then to spin a turbine. And in spinning the turbine, I can power a generator which is going to create electricity. So this electricity then can be piped all the way through wires from the power plant into your home so that when you plug your computer's power cord into the electrical socket, the electricity will flow and your computer will be able to work. If we consider what happened here is that we had a certain amount of energy that was associated with the river in the form of kinetic energy. And that energy then was transformed into potential energy by the dam. The hydroelectric plant then took that potential energy and turned it into electricity, which it was then able to travel to your home and power your computer. Now, the second law of thermodynamics states that not all the energy can be used. So let's consider another example. Say we have a stalled car and we are trying to push that car down the street. Now, when I push the car moves a certain amount of distance and then it stops, right? It doesn't just keep rolling on indefinitely. So this is the second law of thermodynamics in action. Not all the energy can be used. If all of the energy I applied to the car could have been used, the car would continue to have kinetic energy until I stopped it. However, we know that energy is slowly lost over time, and that causes the car to stop. When I pushed the car, I infused the car with kinetic energy, and those rubber tires began to turn and move the car down the street. However, the rubber of the tire is scraping against the pavement. And as the tires scrape against the pavement, it's going to produce heat due to friction. Heat is another form of energy, but heat isn't kinetic energy. So what's happening is, as the tires roll across the pavement, I'm slowly removing some of the kinetic energy and turning it into heat. I am turning it into an unusable form of energy as far as I'm concerned in terms of moving the car. So if I graphed the total amount of energy in this system over a given amount of time, I could describe the different types of energy that exist in the system at any one point. So the total amount of energy isn't going to change over time. We've established that in the first law of thermodynamics. However, we did say in the first law of thermodynamics that energy can be transformed into different forms. What happens in the real world is we're only really ever measuring usable energy. So in the case of the car, we are only really measuring the kinetic energy of the car moving. If we take into account total energy, at time 0 here, when I've just started to push the car, all of this energy is kinetic. Now, as time moves on and I measure the kinetic energy of the car, that is going to decrease over time until it gets to the point where it's 0 and the car stops moving. If at the same time I was to measure the amount of unusable energy that's getting produced in the system, in this case heat that is being lost due to friction, that is increasing over time. If I was to measure the car at any one point in the distance that it travels, I can see that the kinetic energy of the car is decreasing and the heat that's being lost to friction between the tire and the pavement is increasing, right? And I can make then a prediction about when the car is going to stop because the kinetic energy has fallen all the way to 0. So another way of stating the second law of thermodynamics is to say that entropy or disorder tends to increase over time. What we can do then is we can actually put this concept of this graph into sort of a basic formula form, and I can actually say that the total energy of the system is equal to the amount of usable energy or free energy plus the amount of unusable energy in the system. Okay, so hopefully these examples helped you to understand a little bit more about how the laws of thermodynamics apply to everyday life. The first law of thermodynamics states that energy can be converted from one form to another, but energy can neither be created nor destroyed. The second law of thermodynamics states that not all energy can be used, and disorder tends to increase over time. So if you ever want to give your mom a good excuse for your messy room, just tell her that you're only following the second law of thermodynamics.